Welcome back. In this special series, Johannes and I take his new book, Introduction to Supply Chain, and we go chapter by chapter and go back and forth discussing the merits, the challenges, the problems, the practical tips. For this series, I assume the posture of somebody who does not know Lokad, does not know Johannes, is completely unfamiliar with the quantitative supply chain perspective. In fact, I assume the position of one of the 10 million or so practitioners in the supply chain landscape. Someone who might see this book on a shelf, perhaps in a bookstore, perhaps on Amazon, maybe. Pick it up, start reading, and have questions. And my role in this series is to be your voice. I pose those questions to Johannes and try to get you clarification on anything that you might think is unclear. Now, this is episode 5. If you have not seen the previous 4, I do suggest watching them because things we say today will certainly echo back to previous discussions. And with that, Johannes, good to see you again. So, chapter 5, information. I think in order to frame it, I will actually read to you the opening line of chapter 5 because I think it really does provide a nice lens for the discussion. Chapter 5 begins, every supply chain decision is a bet under uncertainty. To be any good, it must be informed. What do you mean by that, and what is the practical message of chapter 5?
So, the first is I'm pointing out something that should be kind of self-evident. Self-evident is that your supply chain is complex. It's made of many people, many machines, many locations, many inventories. If you are completely ignorant about all of that, I think we can reasonably assume that it's self-evident that your decisions, are going to be very bad. We can go into the philosophical debate of whether you have some kind of prescience or some magic bullshit skill that would let you take correct decisions in absence of information, but that sounds very quickly like not realistic at all. So now, a good manager has to be informed. Decisions have to be informed. Okay, that is kind of directionally what interests us. But what does that mean specifically? What does that mean?
It's what I'm asking,
and the short answer is information has been entirely codified at a mathematical level through the course of the 20th century. Thus, we don't have to guess. This is an area where we have actually extremely high quality scientific knowledge that is extremely dependable. This knowledge is not theoretical. It is literally every single piece of software nowadays use this knowledge in dozens of ways.
Even in supply chain?
Even in supply chain.
Okay.
So any software that you use is using this theory of information knowledge in dozens of ways. Your browser, your phone, the system that you use to do a video conferencing, anything, and your supply chain software also. So my proposition,
You
and
mean
that's
like ERPs? Is that what you mean?
yes, ERP,
WMS,
EPS, any again. This is the theory of information, the Shannon theory.
Yeah.
It is so foundational that it's a little bit like basic arithmetic.
And what is that? by the way?
It's absolutely everywhere, and that's the point. What I'm saying is that. So we have something that is absolutely massive, that is absolutely everywhere. That is, if you remove that, there is not a single piece of software in existence that keeps working. Almost, trivial stuff maybe, but anything that has even like a modicum of complexity doesn't stop working. And yet, and that's my point, how come that I've never seen this theory ever even be mentioned in any supply chain textbook? We have a problem.
When you talk about, sorry, thank you.
We have a
when you
problem.
talk about information in this, again, specifically in the supply chain context, you mean data, right? Or what do you mean specifically?
No, that's the point. Is that this term that was used in a very directional fashion, like information. What is information? Oh, that's what I listen. It's what is being said on the news. Those are information. Okay, that is directionally correct. But what about super precise, mathematically correct, I would say a definition that has like a mathematical clarity, not validity, a mathematical clarity to it. Something that is like absolutely pure, something that is so pure that you can actually process this thing with equations. And that's the point that I'm making. We don't have such incredible theories on everything. There are plenty of things where it is, for example, for intelligence, we don't have like a crystal pure, a high grade, crystal grade purity theory of intelligence. No. We have things that are extremely muddy, extremely confused. So it's not always available. But it turned out that for information, Shannon, one of the most brilliant minds of the 20th century, cracked the problem and gave us a theory, the Shannon theory of information, that is extremely beautiful, simple, and efficient.
And what is that?
So what is that? It's literally, you see, it is literally something that codifies at a mathematical level what information is. And this is not mathematical speculation. It turned out that this mathematical codification is incredibly efficient. It makes software works better. In fact, there is almost nothing that we can do with modern computers that we would be able to do without resorting to this theory. So I know it's a little bit strange to have that, and people have never heard of it. But for the audience that has ever done any bits of computer science, it is as obvious as arithmetics. It is foundational. It is very hard to imagine a world without this theory of information.
Okay. Well, let me read you some quotes, because again, I think the book is 500 pages. So I'm just going to give you a little bit more context here, and that way you can respond a little bit more concretely, perhaps. So again, the idea that every supply chain decision is a bet under uncertainty. To be any good, it must be informed. You also write, mainstream supply chain theory routinely collapses data into information. It treats the quantities it aims to decide upon, that being demand, lead times, service levels, as directly observable. Now, to the 10 million practitioners who read the book and all the followers who are listening who all have a supply chain background, what are you saying to them there, and what does that change? Like, what changes when I take that information in?
First, we need to clarify. That's what I do in this chapter. We need to clarify the difference between data information, and knowledge. Yes. And people, again, they have kind of an directional intuition. But if you press, usually what comes out is extremely muddy. And again, if I look at the average supply chain textbook, it is very clear that the author has no freaking clue about what is the difference between those three things. Okay. Not, again, when I say a difference, I mean, do you have mathematical level clarity about it? You see, because it's very important, because if you don't have a clarity in your mind about those concepts that is of mathematical grade, that means that you cannot use equations. Okay. If you cannot use equations, that means that you cannot translate that into software. So even, again, it is very important, because ultimately what we're describing is that this clarity is not nice to have. It is literally the very ingredient. It's a very quality that makes this thing translatable into software terms. We need, because ultimately software is only basic arithmetics. Software is just that. So if you cannot translate your ideas into, with stages, arithmetics, in fact, you can't even put that into software. So back to data, information, knowledge. Data,
specifically as it pertains to the examples you give, demand, lead time, service levels. How does this theory fit onto this?
So first, data, what is the difference? We need to first approach as data.
Yes.
Data is just the capacity to store 0 and 1s. If you go down, data is just a representation where you have 0s and 1s. Okay. That's it. That is data. Now, the problem is that data, again, if you count in terms of 0s and 1s, it doesn't really tell you about anything, about something that would be like information. We have to get rid. Why? Because let's say, for example, the number 1, I can write it just 1, or I can write it with 1, comma, a million zeros. It's the same number. is the same number.
In French,
But-
it would be
But
point in English, just to be clear.
or dot, yeah.
Yeah, just in case for anyone was thinking.
Yes,
you
yes.
were thinking in
So
French,
the
I know.
decimal separator would
Yeah,
be
yeah,
a dot
exactly.
in English, exactly. And you can pad with 1 million zeros.
Yes.
You, in terms of data, if you add those 1 million zeros, you will have a megabyte of information. A megabyte, sorry, you will have a megabyte of data.
Data, yes.
But do you have more information?
Okay,
no,
there we go.
it is still a number that is like 1.
What it represents.
What it
fundamentally,
represents
yes.
is still the same thing. And so here we are saying that anything can be represented in many, many ways. And some ways are more verbose than other, you see? And so the problem with data is that data doesn't tell you whether what you're doing is verbose or not. When you say, I have 1 megabyte of data, if it's only zeros, you don't have any data. You just have zeros. So then the question, and that was the question being asked by Shannon was, well, okay, what is the something that would be representation independent? You know, we are interested into something that would be the essence of what is in the data, and this essence should be representation independent. And now Shannon was actually thinking about, okay, what are we exactly trying to solve? That's a big question, because okay, we have all those representations, but what is the finality? What is the end game of having stuff represented different ways? And Shannon came with an absolutely stunning, brilliant, and simple answer. Information is ultimately the capacity to resolve uncertainty. So information is, in the purest sense, your capacity to resolve uncertainty. And that's why I say, if you
quote from the book as well, yeah.
it's that's why you can see that this number that I can represent either as just one character or a million, that's why it's doing the same thing. It will let me resolve the uncertainties the exact same way. Thus, it carries the exact same information. And then Claude Shannon goes, much further. He actually once you have this understanding, capacity to resolve information, it gives a mathematical framework to actually understand what is going on. It gives you tools like informational entropy, so that you can actually measure the quantity of information. And that's the thing, is that information can be quantified. We can know, just like you can quantify kilograms, or liters, or you can quantify information in Shannons. So it's literally something that is very interesting, and it proves that it's a fundamental unit. It's a fundamental unit of information.
Okay.
So that's now, and it turned out that because it is so foundational that every single software is built around those ideas, and now the thing is that if we are getting back to supply chain being informed, that's very interesting, because suddenly we have something extremely foundational. We have clarified, again, mathematical grade clarity, what informed actually meant. And that's so important. That's so important because now we are not, having like directionally correct. We have something that is like very, very precise correctness. And that is an instrument that is extremely useful. And again, the criticism that I do implicitly in this chapter is this is an instrument, this theory of information that is so important that, well, it cannot be treated as as a cosmetic detail. It is not like a nice to have. It is something that is foundational, and supply chain practitioners should at least understand what is at stakes with this theory.
Well, that is actually the perfect transition to this question, because again, I was rereading the chapter, as I do, in preparation for these discussions. I was mindful that this might get too abstract, because again, data v information v knowledge can seem quite abstract, and I don't want to lose people, because there are concrete quotes, and I want to read them to you, and then I'll pose you a concrete question so that it becomes a little clearer. So just to summarize in your own words, literally your own words, data are recorded symbols. Information is the capacity of those symbols to resolve uncertainty, as you said. Knowledge is the causal structure that lets a mind, human or machine, and I know you prefer machine, turn information into decisions that improve the firm's returns. You then add, that's 132, page 133, treating raw records, that being data, as if they already resolve uncertainty, is the root cause of dashboards that never decide and planning modules that never plan. So my question is, how can a practitioner know what mode of thinking they're in? Are they just playing around with data? Are they playing around with knowledge? Or are they playing around with information? Because in your view, only knowledge is what makes the difference.
Yes. So here, how do you avoid the confusion?
Yes.
It's very simple. You cannot change the past.
Okay.
So
what does that mean?
That's literally, so you need to think, am I projecting in my mind something where the past is mutable? If you do, you're in big troubles because the past cannot be changed. It's again, it is kind of self-evident, but very frequently what I see in supply chains is mental models where the past is very mutable.
Are you talking about just taking like past data and making your future decisions based purely on that?
The past is literally conceptually at a philosophical level something that can be changed. And that is a problem. Again,
so it can't be changed.
It can.
You're saying the past can be changed.
So according to the mainstream theory, yes.
Okay.
And I say it is very, very weird. And when you think about it, it is very, very wrong.
Okay.
Because the past cannot be changed, obviously.
Okay.
So again, the point is that you have some, that's a sort of first principle reasoning. So we take something that we take as self-evident. I need to make assumption. So I don't want to make like massive assumptions. So I need to make my assumptions, as small as possible. So here I'm just saying, first principle, the past cannot be changed. That's it. It's okay. I'm making an assumption, but I'm not making an extravagant assumption. It feels your perception of the past. There is very few people who say, "Oh."
In what way do people act as if they think the past can be changed? That's a better way maybe to frame
because
the question.
The way they engineer their software, the past is absolutely mutable.
Okay.
The past
for example,
again, every single ERP of the market,
the
past is mutable. It's by design. The relational design. So if you engineer an app following the crude create, read, update, delete, it is absolutely mutable. The past can be changed. It is conceptually a problem, and because
for practitioners,
yes,
in
because
what
that mean again. So you have to think that if the past can be changed, then you are heading for troubles. And now you can think, oh, maybe not, but I would say no. You are going to have problems down the road because what you're doing is something that is so brutally inconsistent with something that is self-evident, like the past cannot be changed.
Okay.
That
from a supply chain perspective, though, what does that mean?
It means that do your equations treat the past as immutable, or do your equations mutate the past? So if you compute something, you have again, you're going to compute numbers. So you're going to have many numbers as input and many numbers as output. Question: do you have a clear boundary between the inputs and the outputs? If the outputs, you see, if your numbers, you have the numbers that represent the past,
like raw transactional historical data.
And this thing, you say, you know what? It's frozen. I cannot touch them ever
because it has happened.
Because it has happened, exactly, and thus I cannot touch those things because they are past. They are immutable.
Yeah.
But now let's imagine, and in software it's very easy, that I build whatever, some sort of logic that has a feedback loop that goes logically into the past. That goes into the past.
Okay. Why would it do that?
Because
for what purpose?
First, it doesn't need a purpose because software is very complex. So you can do a lot of things very accidentally. So you see, it's if you don't enforce a clean environment to say my past is immutable, what you will get is a mutable past. Again, it is just a law of software. Software is complex. The fact that the past is immutable has to be enforced. Okay. If it's not enforced, you will accidentally modify it. So now let's say practical example where the past, because again, the past is muted.
This is I know, but this is very philosophical. And
yes, but the problem is that, again, the problem of supply chains are things that are so massively wrong that people can't wrap their head around because the nonsense has been going on for so long that they're lost. And
that's why we're here, to make it a bit clearer for them.
How do you mutate the past? Well, you have a stockout. Okay, so you have your records, and they say what you've sold. Okay, so I sold 1 unit this day, 3 units this day, 4 units this day, and zeros for this day. Okay. The problem is that the zeros that I've observed in the past, well, we had a stockout.
Yeah.
So the fact
Keep
that
going.
you sold zero is the past. This is the truth. You sold zeros.
Yes.
Fine.
I don't think anyone will contest this so far.
How do you make the past mutable? Now you have a problem because your time series forecasting
There we go.
algorithm, the time series forecasting that you use, does not behave correctly. It misbehaves when you feed zeros as inputs, because in fact you have an impedance mismatch between the past, the semantic of the thing in the past, and the semantic of the past in the future. The past, what you have are the observed sales.
Yes.
So this is the semantic of what you have observed and recorded in the past. The semantic is the observed sales. But for the future, this is not the semantic that you are interested in. The semantic that you're interested in is the future demand. That's the mainstream, supply chain theory. Okay, so the problem is that if I extrapolate time series forecasting style, my past sales, those zeros are going to create a massive downward bias. So
in what way? Sorry, I know, but
it's
imagine
very
I don't
simple.
know.
It's again, if you observe tons of zeros, your model, which is a variant of a moving average of some kind, it's just a glorified moving average with a little bit of a few cyclicities on top, but it's a glorified moving average. So your time series forecasting model, a glorified moving average, will take those zeros and it will be having it will underestimate the demand because it will take your 0 units sold, but it was because of the stockout as inputs. That is the problem that people face. And how do you solve that in a very bad way? Because you forgot that you had the past is immutable invariant, So how can you solve that in a way that is profoundly misguided? You make the past mutable. What do? You rewrite the unit that you sold to have something that would be the plausible demand for this day. So you modified your past data and you replace your zeros that were what you effectively observed by plausible demand for the day. What you've done is that you've changed the past.
Okay.
And it is very inconsistent. And guess what? You will end up in a world of pain because what you've done is so logically wrong that it cannot be any other way. It will cascade into all sorts of problems. You see, and again, people might think that...
I'll let you finish this point, but there's a key detail there that I think you need to unpack, which is you've described the mechanism of being wrong, but you haven't explained the pain of being wrong. So you've said, it's logically wrong. Okay, that's the mechanism.
Yes.
What do you feel as a consequence of being wrong? That's the consequence.
The consequence is your allocations. We are back to economic problems. Your allocations will be out of whack. So that means that you will effectively misallocate your capital, and thus you will have a rate of returns that is much lower than the one you should have. You see, so that the thing is that any allocation, good or bad, gives you a rate of return.
Of some kind, yes.
So, and if you're lucky and you're in a very nice sector, even bad allocations can sometimes yield a positive rate of return. But again, the game is you want to have the maximal rate of return. So fundamentally, the pain will be diminished rates of returns for all the allocations.
Less money, essentially.
Yes, less money. Yes, and that's always a problem. If you manage your company improperly, the sanction is that it is less profitable.
Yes,
that's it. And here you have to understand that. And what I'm just saying is that this invariant, you should not be modifying the past, is extremely important. And you cannot play with this invariant because it is so logically inconsistent that no matter how clever you think you are, it's going, to have, I would say, very bad consequences for your supply chain. You cannot defy this sort of principle. It's like if you read causality the wrong way for a business thing, if you think that A cause B, but in fact the reality is that it's B cause A. If you misread the situation that way, it will cause economic damage. It's a sort of deep misunderstanding that will echoes and create all sort of problems along the road, because it is fundamentally you're doing something that is so wrong that it will have negative consequences. And those negative consequences will be incredibly varied. They will be incredibly diffuse, and because it's supply chain, it's complex, etc., it will be all over the place. And then it will be very difficult for you to diagnose what is the root cause. I tell you, you can go back to the root cause. The root cause is you cannot violate you cannot make the past mutable in impunity. That is just as simple as that. And it's not. And when I say impunity, do not think of it as a moral judgment. It's an economic judgment. This impunity will be paid in dollars.
Okay. I'm going to push forward a bit on this point, because there are at least two other core pillars in the chapter. But between them is another issue about data. And in the chapter you talk about, so you mentioned earlier, data are just recorded symbols. They represent something, you interpret them as you will. Now, you push back on the idea that data is often scapegoated as the cause of financial losses and failed programs. You make the claim that, and you've said it actually publicly, we've done live events before where you've said, like, your data is not bad. If you have transactional data, basically, depending on what software you have, you're good to go. So this is, again, another example of where your perspective and, let's say, the mainstream perspective will be at odds, because you and I have both heard, I don't know, let's say 100 to 1,000 times. That's the order of magnitude. My master data is not good enough to start a new project, whatever. You clearly disagree with that idea. Why?
So if we go back to the fact that the past should not be mutable.
Yes.
But the reality is that the way supply chain in practice, and again, it is practiced with software. It has been practiced with software for the last 3 decades. So I do not know any supply chain of any scale that doesn't have software right, left, and center. It's software is all over the place. But if you do not have like a very clear boundary between the stuff that represent the past and the stuff that speculate about the future, it's going to be a massive mess. Yeah. It's just, again, software is complicated, software is complex, supply chain is complicated, and supply chain is complex. Yeah. So if
complexity is all the way down.
Yes. So if you do not enforce, you must enforce this environment that you have a class of software that deals about the past, and that's going to be called system of records.
There we go.
And then you have a class of software that deals about the future, and that will be called system of intelligence. If you do not segregate those two, and you maintain this segregation, guess what? You're going to have a hodgepodge mix that is going to be so confused that nobody understands anymore what is going on. And thus, you will ultimately blame the data, because you would say, oh, obviously we had so many problems, it must have been bad data. And bad data is a scapegoat that is very convenient, because data not being a person, you don't blame anybody. It's when people blame data, it's as if they were blaming the universe. And you see, it's okay. I mean, and if you go back in antiquity, that would be just like, primitive tribes that were blaming some kind of gods for their problems. It's obviously we are too modern to blame a god. So we are not going to blame a god. We are just going to blame a modern construct so that it feels so much more modern. So we are going to blame data, and instead of blaming the god of supply chain. But from, I would say, a rational perspective, this is exactly the same thing. When people say, oh, my data is a problem, what I hear is I'm blaming the god of supply chain or the god of IT. It's something like that.
Well, to be fair, and now I will draw on my previous knowledge, because I do know that your position is a little bit more charitable than that sounds. Like, that sounds very absolute. No, but like, just to be fair.
I'm pressing the point.
Yeah, you're pressing the point, but to be fair, you've previously said, and I am paraphrasing you, but in effect, data is not bad, and your point being that, look, transactional data is what it is.
Yes.
But you have made the point that it can be tricky because there are semantics. Yes. And I don't think you mentioned in this book, I believe it's, if I'm recalling correctly, it's actually in your first book, the Quantitative Supply Chain Manifesto, the big red book.
Yes.
And you gave the example, it's one of my favorite examples, and I've pitched it to you before, like, what does sales mean? Like on a day, is it
Yes.
like if you open a ledger, what is that? The sales that happened on Monday? Is that the sales that happened on Monday? Is it when the warranty period expired from sales 2 weeks ago? Is it what you? There are about 10 or 12 or 15 or 1,000 ways you can slice sales
Yes.
units per day.
Yes, and that's, you see here, the to understand that is that the data about the past is immutable. Think of it like the documents of an historian. The documents are just the documents. So when an historian is working, the documents are immutable. You know, if there was, for example, a treaty signed between two countries at a certain date, this treaty is perfectly recorded. This treaty do not change.
Yes.
But there might be so many subtleties that are lost in truly understanding what was going on. So the historian, what the work of the historian is to actually revisit those facts, those records, and build a new understanding of what happened.
I like this metaphor.
You see, and what I'm saying, in the work of an historian is extremely difficult.
Yes.
Because in fact there is, yes, the records are, non-ambiguous, but the interpretations that we can have of those records are infinite. And that is the same for software. So your software, let's assume for the moment that your software is properly designed. In practice, it's not, and that it's really a software that is mindful of this, of making the past immutable. Fine. So now you have a clean software where the past is immutable. You have clean records that are not, constantly moving under your feet. That's good. But I'm not saying that understanding those records is easy. Understanding those records can be extremely complicated. And that's why you don't want to make the situation worse by having some kind of feedback loops that re-inject stuff into your past. Just think of it as an historian who would be working with historical documents, but imagine he has like a library that say, oh, here it's my collections of documents about what happened in France in the 17th century. And that's the list of documents that I have. They are the reference, for my understanding. And now imagine that this library, you have people who insert forgeries all the time. So they insert fake 17th century documents in this library all the time. Then the historian would be completely lost. They say, now I had one problem which was already very difficult, was making sense of this time period, and now I have another problem which is getting rid of all the forgeries that were actually created after the time period I'm interested. You see, that would be such a nightmare. So obviously historians are extremely precise in making sure that all the documents that they have are actually of the right period, and they are not like forgeries that were made after the fact. And that's what I'm saying. So that's why what I'm saying is that we need to have to make the past immutable, but making the past immutable, which is the first step, that system of records, it doesn't make the past easy to apprehend. You see, it remains extremely difficult.
Which is why you talk about you need specialists, supply chain specialists who can
Yes.
parse the semantics.
And exactly, and it is difficult, but not because those observations are are garbage. They have not been polluted with forgeries made after the facts. They have some kind of intrinsic difficulty, which is it is very difficult to interpret what. When I say the past sales, it is a very ambiguous statement. It is a very ambiguous statement, and that's where ultimately where knowledge come into place. Knowledge is being able to resolve this ambiguity so that you can turn this information into something actionable. You need to resolve all those uncertainties, all those ambiguities. I would say, not uncertainties, ambiguities.
Okay. Well, I do think it's time to address what I would say is the central pillar of the chapter, and certainly something that speaks even beyond the book itself, because it's aimed at practitioners, but this gets into just the entire concept of where does a company allocate its money, and that is systems of records, systems of reports, and systems of intelligence. So systems of records, your ERP, whatever, the historian of the company, to use your own analogy, where, like, what happened when, that's in the past.
It is not the historian. It is the system of records is literally the clerk.
The clerk.
Excuse me, it's just the guy who
writes
takes
down the
notes,
numbers.
writes.
The digital version.
Exactly, it's a digital version of the clerk. Someone who is just keeping the records. He's not trying to have any intelligence. He's just recording as it is.
Yeah.
The good, the bad, the mistakes, and the greatness. Everything as it is. That's it.
Okay. Systems of report, that is the business intelligence tools, representations of that.
So system of reports are used for something very different. They are used for compliance.
Yes.
You see. So what does that mean? That you're going to say we have processes, we have rules, we have best practices, and the management just need an instrument to enforce that. So the systems of reports, they are not about gaining intelligence, understanding the future or anything. They are essentially an instrument for a large company to maintain compliance with its own processes, and that's it.
They want insight. They want a visualization of what's happening.
That is what vendors who are selling business intelligence say. In practice, I've never seen use those tools that way. They are only used. Nobody is really earning any insight. I mean, yes, very occasionally, someone will have an insight looking at a business intelligence report.
But that's not the purpose of that brand or category of technology.
It is so infrequent. For me, it's, again, a weak analogy, but it is so infrequent that it is a very, very secondary. It would be saying like alcohol is something that you can use to make scientific discoveries. Yes, occasionally there will be a scientist that will drink a lot of alcohols, and in this state of, altered mind state, they will make a discovery. But saying that an alcohol is an instrument of science is a little bit, it's a little bit pushing.
Now you're making a teleological argument, and actually allow me just to set the table a little bit more, because I think then we can take the idea a little bit more universally. So again, You've explained at length systems of record. That is the clerk. It's just the records of what happened.
Yes.
Your systems of report. That is visualization tools like business intelligence. It is not for decision making.
It is sold for decision making.
It is sold, but in your category.
In practice, companies who operate supply chains are extremely large, complex, and thus staying consistent with their own proclaimed processes is very difficult. You just remaining compliant with your own processes, your own rules is very complicated at scale, and that's where systems of reports are very good at. Is that they let managers check if their underlings are sticking to staying true to whatever compliance mean in the company.
Well, you've actually said. Sorry, my own microphone is in the way. Hang on a second. Most corporate disappointments come from conflating these different systems, expecting ledgers to think or analytics layers to serve as sources of truth. Now, that sets up the category that you have yet to expand upon, which is systems of intelligence. And I, again, having read the chapter, realized that is where you believe decisions and better performance actually lies.
Yes.
And that is... So please explain, I would say somewhat tersely, what a system of intelligence is, and fundamentally why you should not treat the other two classes of systems as if they were a system of intelligence. So that's core, by the way. That's a core point.
Absolutely core. So the first one, system of records, is the past. It's a record of the past. It's the best thing that you have about the past. Now, the system of reports is also about the past. It just tells you if you were compliant in the past with your own processes. So it's very much backward looking. So you see, this system of reports just tell you a story about the past. It's a way to build a narrative about the past, if you want. It's not very elaborate. It's just, again, that would be just like, for example, economics history. Where French people, richer or poorer a century ago, that is just what the system of reports will give you, instead of having millions of records about earning statements of French people. You would have aggregated statistics. That's what you have.
We've covered these two, though, so let's get to the intelligence.
And the first one, the third one, it's something very, very different. It's the only one that is actually looking at the future.
Okay.
And in what ways?
By design, looking at the future.
It's by design because what it's trying to achieve is to generate decisions.
Yes.
So a decision is always forward-looking.
Mm-hmm.
You decide something because you think that you will have some kind of payback. That's why you make this decision.
Mm-hmm.
And I've clarified that in the specific case of supply chain, a decision is an allocation of resource.
Yes.
So an allocation of resource. So you are essentially allocating a resource because you expect a return on investment of some kind at some point. And your system of intelligence is just a machine to generate those allocations for you. That's it.
It's actually
nothing less, nothing more.
Not to cut you, but even still, just to underline the point, even if you make your decisions based on things that you've criticized in the past, like I want to maintain high service levels, even if that's the case and that's your guiding star, it's still because you want a desirable return on investment.
Absolutely.
So
and
that's the
again,
overarching goal.
Yes. And again, you can have adequately designed system of intelligence or inappropriately designed system of intelligence. The only difference will be the rate of return that you get out of your decisions. But first, you see, you cannot bypass the fact that a system of decisions exists. Why? Because resources are allocated. That's it. Resources are allocated. So the decision is being made. It is. You cannot bypass that. The resource will be allocation. You are, as a company, spending your dollars all the time to buy raw materials, to buy inventory that you replenish. You are giving tasks to your own employees to do something. So that's an allocation of resource. Those things happen all the time. They cannot be evaded. And what I'm saying is that a century ago, we had a very clean situation. Systems of intelligence were exclusively human. So the records were already part machines, because the records, even a century ago, it was written down in books. So in a way, the storage was already something that was inhuman. It was not in the mind of a person.
You weren't carrying this information in your head all the time.
We were carrying through devices already. Obviously, they were not sophisticated, but they were devices.
Yes.
And they could store already through books quite a lot of information. So we were already having for the records essentially, artifacts. Computers are better artifacts, but we already had artifacts. When it came to decisions, the thing it was just purely human. But now, for the last 3 decades, what we have is a mix. Nobody has a purely human decision layer anymore. It doesn't exist. Even when people say, "Oh, we do everything manually," I say, "Do you?" Oh, yes, everything is done manually. We're just using Excel. I say, oh, okay. So, Excel is very much software. Excel is software. Excel is like an extension of your minds to do tons of basic arithmetics. So we already have some kind of an hybrid system that is human mind plus machines. As soon as you have an Excel spreadsheet, it is an hybrid system. It is software plus human mind, both. And over time, what I've seen is that the software portion has just gone bigger and bigger and bigger. And even if it was nothing more than Excel spreadsheets, because guess what? Excel is itself a moving target. Excel, if we go back 20 years ago, was max 65,000 lines. Now it is 1 million lines. Thus, Excel over the last 20 years, it expanded in capabilities. And now you can even have, Python script in your Excel spreadsheet. So Excel itself became more powerful. And there are plenty of things that became more powerful because, for example, people say, I'm just using Excel. But are they just using Excel? No, they're also using the capabilities of their system of records and reports to generate extracts that are used as inputs for their spreadsheets. So effectively, it is not just pure Excel. It is a mix of the applicative landscape that is generating inputs that you're putting, etc. And what I'm saying is that overall, the portion year after year, the portion that is used, that is, I would say, delegated to the machine is growing bigger and bigger and bigger. That's what I'm saying. And thus, we need to put that under control.
You've also, again, in the chapter, you advance the argument that real scalable profitability is to be found by investing more in systems of intelligence rather than systems of records. Now, we've previously discussed on other episodes that the spending, it tends to be very asymmetrical. So, for example, the majority of spending might be on systems of records, even though you make the argument they don't generate decisions or do like that. I've got the most sophisticated accountant or ledger ever. That does not get you to a better decision. So why is the spending so asymmetrical?
Because again, software is a big complicated thing, and people treat software as if it was like some voodoo magic that happens within the offices of the vendors. This is not. Software is certainly basic. It is certainly not voodoo magic.
It's portrayed by some vendors
yes,
as
yes,
like
and because
black box
for
magic,
vendors they say, I have a secret recipe.
Yeah.
I have a magical ingredient that you cannot replicate or something. And that's like again, this is just essentially bullshit talk to promote your products. But it's not rational. It's just again.
And to be fair, in case anyone accuses Lokad, our documentation is publicly available.
Yes.
People could engineer it if they wanted to, but they can't. Just to forestall that criticism. But please continue.
Yes. Now back to the software. What I'm saying is that if you maintain your very clean environment, like you have a class of software that is only dealing with a BAS, that is system of records. If you enforce this environment, then suddenly you realize, oh, this piece of software that is only dealing about the past, it is just a glorified version of my accounting books. It's nothing. There is nothing to it.
Yeah.
It's just a long series of records. And guess what? Hard drives are cheap, so I can have my billions of records, and it will be cheap. And thus, should I pay top money for that? No. It is simple. Thus it must be cheap. Do you think that as a software vendor, you want your client to realize that what you have in your hands is like something that should be like super cheap? No. So you're going to mystify the client. You're going to mystify the client, and you're going to create a whole layer of confusion so that people are lost and they don't realize that at the core, what you have is something extremely simple. A system of records is extremely simple. This is just a glorified ledger. Nothing else, nothing less, nothing more. It is super straightforward.
But people will spend, companies will spend $500 million on a system of record.
And yes, and why? It's because
exactly.
the vendor.
Why,
it's because the vendors, enterprise software vendors, are extremely good at making their products desirable. So they will create an enormous amount of confusion, so that people think, oh, this software, it is so much more. It is, and I say, no. What you're buying is an illusion. It is not more. If you're buying an ERP, you are buying a system of records, and thus this thing should be very cheap, very lean, and that's it. And then if you're facing a software vendor that is starting to mystify you by explaining, oh no, my ERP, it does everything. It has AI, it has this and that, etc. You are being mystified. That is my message. You are being mystified. It is as if an accountant was telling you, I'm a rockstar accountant. I do magic. Profit comes. The way I count the numbers, you make more profit. Just pause for a second.
Imagine the way I count. That's actually a better line right there.
An accountant that would tell you, thanks to my great accounting, I can generate so much money for you. We are going to create money out of thin air. It sounds like fraud. It sounds like fraud.
Yeah.
I mean, an accountant is not supposed to be able to create money out of thin air. The accountants that are capable of doing that are usually doing things that, Enron style.
They work for the syndicates.
or Enron, Enron, they had like accounting shenanigans that were extremely creative. I give them that. Enron had like extremely, extremely creative accounting.
You admire the moxie. Yeah.
Yes, they were like pioneers of avant-garde accounting techniques, and it's really not good. It's really, really not good. So again, you do not want your ledger to be the place where you have innovation. This is the wrong intellectual. You want your ledger to be, you do not want an inventive accountant. You do not want a creative accountant. You want a diligent accountant. You want a reliable accountant, and you want a cost-efficient accountant. That's what you want. And by the way, all those qualities translate to your system of records. They are the exact same.
Yep. So this is a key point. You touch on it in the book. I know you've also talked about it in other videos, and we don't need to get in. We've already been going for almost an hour. We don't need to get into the heavy software architecture. But what you just said there, like you want your records to be diligent. You want your records to be snappy. So again, key difference here. A decision, just to compare these two, because I think they're the two most often confused classes in this designation. You have systems of record and you have systems of intelligence. In the book, you describe decisions are laborious. Because to make a good decision takes time. Now, the software architecture required to support that is the opposite of the software architecture to make a record accurate fast. So again, to be very concrete, you're in a warehouse. You're in a store and you're selling things. You want to know how many units are there. You want to know how many units are in the warehouse. You want to know that as accurately and quickly as possible.
Yes.
Now, that's what a system of record is for. Now, you know better the design, but you've made the analogy before that the sports analogy, that you can be very, very fast at running, like a marathon runner, the best in the world, or you can be a powerlifting champion. Yes. It's very difficult to do both because the better you get at one, it comes at the cost of the other. Exactly. So please expand on that in better words than I just did.
So again, the accountant analogy is how many rock stars are in their pastime accountants? None. Because if you have the temperament to be a good accountant, you don't have the temperament to be a rock star. And vice versa. If you see, you would never trust your accounting to someone who is taking drugs, who is doing wild things.
So decisions are rock stars in this analogy?
Decisions are, yes, a little bit. There is a little bit
because they're innovative, they're creative.
They are very creative. They fundamentally what you're trying to do is to achieve greatness.
There you go.
And the accountant is not there to achieve greatness because greatness in accounting means end run. You do not want you do not want greatness. You don't want innovation.
Snappy precision.
You want you want something that is always the same, reliable. Boring.
There you go.
Boring is an incredible quality for an accountant.
Yes.
I would even say if your accountant is a very interesting guy, I would not maybe trust this accountant. Again, it's a matter of personality. It's a matter of personality. The great accountant is someone who is so reliable that he's boring. That's what you expect from an accountant. Yeah. And from a rock star, this guy can be completely unreliable. But guess what? Sometimes he has a strike of genius and boom, greatness. That's a great decision. That's the sort of things that you expect at the decision level. It is not, and because again the future is uncertain, so it will always be a gamble. That's why I say at the decision level you are always speculating. There is no other way. You do not know the future. Thus, there is an element of risk, and that's why you can have an element of greatness. Is that if you're very, very good at the way you see the future, then you can achieve something that is incredible, which is very, very high rate of returns.
I think so. Again, I certainly like the accountant element of that analogy. I just want to pitch to you. You can tell me how you feel about it. To use the musical analogy, how I perceived it was accountant is your system of record is an accountant. You want it to be sort of mundane, reliable, dependable. The system of intelligence is like Bach or Mozart. They will compose. It will be laborious. It's intensive. It's creative. It's enigmatic. Like a really good allocation or replenishment. That's like I'm taking symbols from all over. It takes time. It's effort. The system recomputes and computes. And at the end, you have Fur Elise. You have one of the greatest pieces of music of all time. The rockstar makes it sound like chaotic.
Yes.
But to me, the way I perceived of it as like
classical music would be a better,
it's precise.
Yes.
It's
there is
baroque.
Science to it.
There's science to it. The beats, you want everything to fit within parameters.
But also, if you have true greatness in classic music, which would be indeed a better analogy, is that you cannot enforce boundaries. Geniuses where even if they are extremely codified and strict, it's never within the boundaries, because you see, true genius is redefining what music should be, redefining the boundaries, pushing those boundaries not randomly, but with purpose. And that is kind of the opposite of the accountant that is not supposed to push the boundaries. The accountant, a good accountant, is by definition, again, you don't want end-run situation.
That's the point.
It must be boring, it must be constrained. If you're in decisions, yes, it's Mozart. You have to push the boundaries of what music can be.
Yes,
and that's how you have like this true greatness. Yeah. And that, yes, the analogy really works on this stage.
Okay. Well, again, and then we come back to why is there well, I suppose you can actually apply this to both music and to systems of intelligence, but why is there overall in the industry a seemingly systematic, pardon the pun, systematic underappreciation for classical music / systems of intelligence?
So now we need to have a look at the incentives of the software vendors. So what is your incentive? You want to sell at the highest possible price the thing that costs you the least to produce. You know, that's I'm a software vendor. I need to make money. So I have the money that I earn, that's the price that people pay. And what does it cost me? It's the price I pay as a software vendor to have the software produced. So far, you know, software industry is just like production. You want to essentially buy low, sell high.
Buy low, yeah, that's the way.
That's it. Now, a system of records, as I said, is very simple and thus very cheap to produce. Great. For me, as a software vendor, great. Why? Cheap, low cost of production. Excellent. Now the problem is, I've produced a piece of software that is cheap. Now the willingness of the client is not that good. You see, yes, my costs are low, but the willingness of the clients to pay is low as well. Not such a great place. So, but imagine that if I mystify the client about exactly what my software does, I can inflate its willingness to pay enormously. Oh, there will be a problem. Is that if I want to do that, to do this magic trick, I will need magicians to do that, because it's kind of a magic trick. So I will need to have those magicians. Who are going to be those magicians? That's going to be the enterprise software vendor guy. You know that, and guess what? Those enterprise software vendors, if you look at their workforce, they have up to 2/3 of their workforce are actually vendors. They are salespeople. So the cost of an enterprise software vendor, your typical not Lokad, but the cost of your typical enterprise software vendor, the 2/3, you're not paying for the software being produced. You're paying for the cost structure of selling the software. So essentially, you are paying a vendor for the magicians that they have that are creating the illusion that the software is so much more than what it is, and thus they are inflating your willingness to pay. You would say it's so simple, but guess what? It is simple. It is simple and it works. Thus, tons of enterprise software vendors are doing exactly that. You take a piece of software that is cheap to produce, then on top of that, you take people that are, enterprise salespeople, and then those people will do the voodoo, and they will, that's their professional competency, they will inflate the willingness to pay of the client. And at the end, what you have is you have companies who are paying extravagant prices based on extravagant expectations that are going to be disappointed every single time, because ultimately what they're buying is something that cannot deliver ever on its promise. That's it. And this story, unfortunately, has been repeating over and over for the last 4 decades.
Which means we've been going for an hour, and I think it's about time that I ask the closing question, but it builds on not only what we've discussed today, but honestly the previous 4 chapters, and which is, and I think it's probably one of the most consequential questions, again, not only just for practitioners, but for the companies in which they work. You've outlined systems of record, systems of report, systems of intelligence, the functions of each, where the value lies in each. Okay, how can practitioners who may not have your level of expertise in software and design and architecture and whatnot, how can they tomorrow, if they enter a conversation with a vendor to buy an ERP, a system of record, how can they know, am I about to get ripped off here? Am I being sold snake oil?
You need to ask the basic question, is your software mutating the past? I know it's a strange question because you say, oh.
You want them to ask that to the vendor?
Yes. Just ask the question. Do you mutate the past? That's it. It's a very simple question. Do you mutate the past? And where it ties to information is that when we finally understand how information works, etc., in fact, what you're doing is that you're asking a simple question that is a litmus test on whether the software is enforcing a fundamental invariant or not. If the vendor is baffled by the question, then it's a terrible answer because it means that the vendor has no clue about what it's doing. If the vendor has no clue about what it's doing,
probably shouldn't buy it.
You shouldn't buy it. Imagine. I know software is so abstract. People tend to lose their mind. But let's go back to a question for a car. If you ask the question for a car would be, is this car safe? And if the vendor was saying, what do you mean safe? I don't understand your question. And then you would be, I guess I will take another car. I prefer to buy a car from a guy that tell you, oh yes, our car is very safe. It has safety belt. It has airbags. It has a design where the engine, if you collide something, it will go under you instead of crashing your legs. You see, that is a good answer. That is that's the vendor that you want is say, oh, mutability of the past. Oh yes, that's such an important concern. We have paid a lot of attention to it. That's a simple thing. It's just if you ask a car, you're buying a car, you ask, is it safe? And the vendor tell you,
is it safe?
I've never really thought about it. That's just not a good answer. That should be a terrifyingly bad answer. And I'm just saying, again, software is easier and simpler than you think. You should just ask your software. Are you selling me a software that is dealing with the past or dealing with the future? If it deals with the past, do you do it in a way that is clean? So you do not mutate the past. And if you're dealing with a software that is about the future, then do you have something that is like a clean separation and you're not trying to mix everything together? So you see, you need to ask those basic questions. And then this sort of information is just a way to kind of understand why we need this clean separation between past and future, because ultimately it's something that it is about those information. What counts as an information only comes from the past plus your knowledge on top to generate the decisions. The knowledge is not looking toward the past. It's fundamentally something that is looking toward the future. But again, you need to have those building blocks, intellectual building blocks, so that you can challenge the software, your software vendor in very simple ways. And again, if when you ask the question, does your software mutate the past? If the vendor is baffled, you need to run. This is bad. This is really critically bad. This is just as bad as an automotive vendor that say, safety, I have no clue what you're talking about. Again, you should run. If you have, you see, those are important, simple questions that you can use, and that's what I would suggest. That's why I suggest to read this chapter. You need to be able to ask those painfully simple questions. They will be excellent litmus tests to detect dangerously incompetent vendors. That's all that I'm saying.
Yes. A potential other way to frame that, and you can let me know what you think, is so you gave the example of a car.
Yes.
And what I thought while I was listening was, okay, it's like if you were buying a sedan, so like just a regular family car, and you say, all right, can I drive up hills? Can I drive up mountains in this? Will it be fine? And if they say yes, somewhat skeptical. Now, to map that onto the software analogy would be, you're buying an ERP and you ask, can I do can this make better decisions for me? And they say yes. To me, a question might be something like, well, I'm a novice, but my understanding is computations required to make decisions are incredibly intensive. And in a single piece of software, that will impede the low latency of a system of records. How do you mitigate that? Just explain to me how you mitigate that. Yes. And if they have no answer to that, I would be skeptical because, again, the requirements to be good at computation comes at the risk of records.
I would say yes, but the problem is that I've been thinking, you see, this is a good question, this is a good test. The problem that I see is that your typical enterprise software vendor is going to give you an answer that you will not understand, and it will look smart and coherent. That's why I prefer to ask for facts. Like,
but those are facts too.
No, it's not a fact, because it's going to be they will. You see, the problem is that
they can lie. I'm not denying they could lie.
The problem is that there are ways to make it work.
Okay.
You see, you can mix system of records and system of intelligence, but there is a catch. It becomes exponentially costly. That is why, for example, you can mix, and you have a very simple example. Google is doing that. So they have a clean record of all the web, plus a system of intelligence that can decide in real time, all together, mixed together. So they have both the system of records and the system of intelligence all together to give you brilliant answers. So it's possible to mix the two. But it is possible. But it costs a lot of money. Really, it's exponentially more costly for the vendor. And it also costs incredible talent. So, bottom line, can you have something that is good at both system of records and system of intelligence? The answer is not no. Okay. The answer is yes, with tons of money and tons of talent. And guess what the vendor is going to tell you? Oh,
that's me.
That's me. That's exactly me. That's exactly
for much
me.
less than you think.
Exactly. And so here, what I'm just saying is that it's too good to be true.
But there
it's
you go.
Too good to be true.
There you go.
Yes.
If it sounds too good to be true, you're probably being scammed.
It's too good to be true. And it's so difficult to compete with Google. It is so difficult to do those sort of things together. And the costs are so staggering that the likelihood that you are actually someone honest is, again, I would say you have to be skeptical. So I think it's a good question. But the problem is that the vendor, it will be so easy to lie to you, because they would say,
AI.
We are so good, Yes, normally it shouldn't be possible at this price point, but we are so good that it is possible. And then you have to call, you're bluffing. You're just bluffing. Sorry, because you see, the problem is that then you have another sort of test, is that if you had people that were that good to do something that is that grand, you would not be doing supply chain software. You would be doing something that would make you even more money. You see, it's just imagine if you have teams that are as good as the one of Google's, even better, and can do things even more incredible. Then why don't you compete with Google to just crush them? And maybe you don't do that because in fact you don't have those teams. And if we are back to it's too good to be true. Let's go back to the M5 competition. The M5 competition, it was a competition about forecasting. Okay, forecasting. Every single one of my peers, my competitors at Lokad, if you go on their website, they will tell you state-of-the-art forecasting. We are the best. They all tell you we have the best forecast. Sometimes it's not that blunt, but it's if it's not stated bluntly, it is so strongly implied that it's like really in your face. So, situation is we have 100 enterprise software vendors who are all saying we have state-of-the-art forecasting models and that are really, really pushing the boundary of what is possible accuracy-wise. Excellent. Okay, why not? Now, the M5 was 1,000 teams competing worldwide. If you look at the top 100, people can verify, it's a Kaggle competition, so the records are in the public. Anybody in the audience can verify what I'm saying. You can go and look at the Kaggle records, and you look at the top 100 people who, for these worldwide competitions, who was part of the top 100. The answer is there was not a single enterprise vendor. Oh, wait, there was just one enterprise software vendor in the top 100. It was Lokad. And all the others were absent.
It's number one at the SKU level, if I recall
Yes,
correctly.
we were one at the SKU level and number 5 at the aggregated level. Initially number 6, but then someone was disqualified because they actually just cheated. Okay. And so we were like after the fact, we were like re-ranked as number 5. Okay. But you see, that's why I say too good to be true. if people are so good, there must be some side effect of of greatness. It's again, it's companies like Facebook are, for example, pushing the state of the art in AI. They are.
Yeah.
And how is it? How do you see that? Well, they have invented many of the technologies that are used by everybody. For example, PyTorch, which is used by like 2/3 of the deep learning community, is a product that came out from the Facebook labs. I mean, Meta nowadays.
Yeah.
So you see, it's if you have great engineering, and Meta has great engineers, you have as a kind of accidental byproducts is that you have great technological piece that comes out of your labs. Or achievements of some kind. Again, Google, same thing. Google, for example, they invented transformers. The Gen AI thing was essentially, this revolution was essentially started at Google. So again, that's a sign that they had a true, I would say they had truly great engineers. If we go back to people who claim that they can do system of records plus system of intelligence, and because they have people that are so great, I would say, okay, but where are the proof of this greatness? What have you achieved that would kind of tangentially prove that you have that you have such a incredible workforce? And very frequently the answer is there is none, because in fact, again, you're in the business of doing system of records, which is boring, which is not interesting, which is not technically challenging. And guess what? You're not going to even need the very best engineers, because if you're doing system of records, why would you want to pay top money for top-notch engineers that you're never going to even need? Because what you're designing is actually fairly simple. You don't need those people. So why would you hire them in the first place? The short answer, you don't.
All right. Well, Johannes, we've been going for quite a while. I don't have any further questions. Thank you very much as always, for expanding and indulging me as I push back on you. I hope I wasn't too firm today. But again,
you're fired.
Fired, exactly.
Fired.
Exactly. This is this is my last stand. This is Custer you're looking at. But yeah, as always, I'm just trying to get to the heart of what I think is a great book with some really, really, really good ideas, and I'm just trying to push you to make it clearer to people who don't already know you. Because obviously, when I read,
and who have no reason to agree with me,
and I have no reason to agree with you, exactly. So I'm trying to push back. I am playing the devil's advocate, which I know you've asked me to do.
Yes.
And to you watching at home, thank you for your questions. Many of the questions I posed to you today, Johannes, actually came from the audience. So, and reading more quotes to contextualize, also feedback from the audience. So, if you have any other feedback, or you just want to reach out and continue with the conversation with Johannes and me, you can connect with us on LinkedIn or send us an email at contact@lokad.com. And with that, we'll see you next time for Chapter 6. And yeah, get back to work.